For decades, astronomers have been listening to the whispers of the cosmos. But lately, they've started hearing shouts. We're talking about these brief, incredibly powerful, and totally mysterious signals that are zapping us from the deepest parts of space. So today, we're going to open the case file on what might be one of the biggest puzzles in all of astronomy.
So what is sending these bizarre signals from all over the universe? This isn't just random static. No, these are structured, intensely powerful bursts of energy. They flare up for just an instant, and then they're gone. The real question is, what could possibly be out there that's powerful enough to do that?
And get this isn't some super rare, once-in-a-lifetime event. Oh no, astronomers think that as many as 10,000 of these things could be hitting Earth every single day. They are happening all around us, all the time, basically painting the entire sky with these invisible fireworks. And we're just now building the tools that are good enough to see them.
Okay, so to really get this mystery, we've got to go back to the very first clue. And it wasn't found with some big eureka moment in a lab. Nope. It was found in the quiet hum of a computer, analyzing data that was already years old.
So, the official name for these things is a fast radio burst, or an FRB. And the energy we're talking about here is, well, it's just staggering. Try to wrap your head around this. Take all the energy our sun pumps out over 3 full days. Now cram all of that into a single flash that lasts just a few thousandths of a second. It's like a cosmic flashbulb with an absolutely unimaginable amount of power.
So, the very first FRB they found, it's now called the Lorimer burst, wasn't even seen when it happened. It was kind of like a ghost in the machine. A spectacular burst of energy from way back in 2001 was just hiding in plain sight on some old data tapes. It actually took a fresh pair of eyes in 2007 to look at it and realize, whoa, this is something completely new.
All right, so with that first clue uncovered, the hunt was officially on. Astronomers started digging through old data, pointing their giant radio telescopes at the sky, just hoping to catch another one. And as they found more, they started to piece together a profile, a kind of facts of the case for a mystery signal.
These are the fingerprints of an FRB. They're crazy fast, just milliseconds long. They come from way outside our own Milky Way galaxy, and they can pop up pretty much anywhere. But the last 2 clues here are the real kickers. That dispersion, that's how we know how far away they are. And the polarization tells us something absolutely wild about where they come from. The light from the burst arrives all twisted up, almost like it went through a cosmic corkscrew. And that only happens when light punches its way through an insanely powerful magnetic field.
Let's dig into that dispersion clue for a sec. Think of it like a race. As these radio waves travel across billions of light years, they run into stray electrons in space. The high-frequency waves, they're like the sprinters. They just zip right through. But the lower-frequency waves get slowed down just a little bit. By measuring that tiny delay, astronomers can figure out exactly how much stuff the signal had to travel through, which tells them how far away it is. And this cosmic yardstick confirmed it. These things are coming from other galaxies.
So the question becomes, what kind of object in space is both ridiculously energetic and intensely magnetic? Well, astronomers put together a lineup of the usual cosmic suspects. We're talking the most violent, most extreme objects the universe has to offer.
At first, the theories all pointed to cataclysms, events that completely destroy whatever caused them. Like 2 neutron stars smashing into each other? Yeah, that would definitely have enough energy. But there was a huge problem with this idea. Some FRBs repeat. And a collision, well, that can only happen once. It's a one-and-done event.
And that brings us to our prime suspect, the magnetar. Okay, so a magnetar is a special kind of neutron star. But its magnetic field it's almost impossible to even comprehend. We're talking quadrillions of times stronger than Earth's magnetic field. It's so strong it could wipe your credit card clean from halfway to the moon. Now that is an object that is both powerful enough and could actually survive letting off one of these bursts.
Of course, whenever astronomers find a strange new signal from space, there's always that one exotic possibility that people jump to. And hey, there's a fun history here. Back when the first pulsars were discovered in the 60s, their signals were so perfectly regular, so clock-like, that the team that found them playfully nicknamed the first one LGM-1 for Little Green Men before they figured out it was a natural object.
Scientists, of course, were betting on natural explanations, and magnetars were right at the top of that list. But for years, it was just a theory. There was no direct proof, because all the FRBs they found were in other galaxies, just way too far away to see clearly.
To really crack this case, they needed a suspect closer to home. And then they got one.
So just to set the stage for this big breakthrough, you have to remember, for well over a decade, every single confirmed fast radio burst was from way, way outside our own galaxy.
We're talking about mind-bendingly vast distances. Trying to pinpoint the source of one was like trying to spot which specific light bulb just flashed in a city on the other side of the planet. It was basically impossible.
And then came April 28, 2020. A new alert goes out. Multiple telescopes see a burst. But this one was different. This one was close. This one was in our own cosmic backyard.
This was the moment the whole case just broke wide open. For the very first time, a signal that looked exactly like an FRB was detected from right inside our own galaxy. And because it was so close, astronomers could immediately point all their other telescopes directly at the location. And there it was, a known magnetar caught red-handed, flaring up at the exact same moment as the radio burst. This was it, the smoking gun. This proved without a shadow of a doubt that magnetars can and do produce fast radio bursts. It was a massive discovery, finally giving us a solid, concrete answer to at least part of this incredible cosmic mystery.
But, like any really great detective story, closing one part of the case file only ended up opening new, even more complicated questions. Just because you've identified a suspect doesn't mean you understand the whole story.
So, case closed, right? We can all go home? Not so fast. Solving the magnetar piece of the puzzle actually made some of the other weird clues we have even more interesting.
I mean, sure, we know magnetars are a source, but are they the only source? And what's the deal with the repeaters? Some of them flash over and over again, but most just flash once and then go silent forever. And then it gets really weird. One of the repeating FRBs seems to be on a strict schedule, a 16-day cycle where it's active, then quiet, then active again. A single magnetar just flaring up randomly can't really explain a pattern that's so precise.
So this is pretty much where the investigation is today. We have a confirmed culprit, the magnetar, but we don't know if it's acting alone. We still don't really get the physics of how a magnetar unleashes a blast that powerful. And those repeating signals, especially the one with the clockwork pattern, they hint that there's a whole other layer to this mystery we haven't even begun to understand yet.
And that really just leaves us with one final, kind of exciting thought. The very first FRB was found by looking back at old data. It was this colossal cosmic event that just sat on a shelf totally unnoticed for 6 years. It really makes you wonder, doesn't it? As we build bigger telescopes and write smarter code, what other profound secrets about our universe have we already recorded and they're just sitting there waiting for the right person to look?